All right, perfect problem 3, solutions for math 251. You're given this graph, and in part 1, let's see, this is supposed to be f in part 1, so this is my function. Guess I'm going to do part 1 right here. And what I am asked to do is to sketch another graph, an approximate graph, very, very approximate graph. Guess that goes out a little further than -4, whatever, something like this. And sketch an approximate graph of f prime. And then add some comments if you want. Okay, it's a little tricky. So the basic idea is you're supposed to look at this and kind of think about what the slope of this thing is at different points. And I really shouldn't say the slope of this, it's the derivative of this, the slope of the tangent line to the curve. I'm just going to say the slope, but when I say the slope, you're thinking that I'm saying the slope of the tangent line to this curve. It's kind of a mouthful. Anyways, note that at this point right here, when x equals -4, if I were to draw a tangent line, it would be flat, it would be horizontal, slope would be 0. So what that means is that right here at -4, if I'm going to draw a graph of f prime, the height of f prime better be 0. Now let's see the slope here. Well, it's decreasing. What's it decreasing at? I don't know, -2 or so. I mean, it's going down at whatever speed you want to call that. But it gets flatter and flatter until you get over here where it becomes 0. So let's see, it's going down, so the height should be some negative number. It looks something like this. Starts out at negative, I don't know, -2 or so. Maybe I won't even put an axis here to make life easier for me. But then it gets bigger and bigger until you get up to this point. And then at this point, I'm right here, it starts going up, right? The slope is now positive. When it gets to -3, we get some weird discontinuity here, but right before -3, it's going up. What's the slope? I don't know, a little bit more than 1, maybe close to 2. So here's -3. I want this thing to keep going up until I get somewhere in here to -3. Because at -3, I have this sharp turn. So when you have a sharp turn like that, it means that it's not differentiable. It means that I have an open circle when I'm sketching the derivative. The derivative does not exist at -3. You can't draw a tangent line here because it's a sharp turn. So I don't want my graph of f prime to have any height at all. Okay, so then what happens? Well, let's see, if I get just to the right, it looks like I have a constant slope, right? It's going down at the exact same slope. What is that slope? Ooh, I don't know. It goes over 1, 2, 3, and it goes down 1, 2, 3, 4, 5, 6. All right, every time it goes down 2, it goes over 1. Nice. Looks like -2 to me. -2? I don't know. Sure, I'll put a scale on this. -2 is right here. I am going to say that the slope when x equals 3 is undefined, but then the slope is equal to -2 all the way until we get over here to 0. In other words, slope stays the same. It's -2, it's -2, it's -2 until we get to 0. Because at 0, it's undefined again. Why is it undefined? Because we're not differentiable here at 0. Right? It's this sharp turn. You can't draw a tangent line. It switches from having a slope of -2 to a slope of 1, 2, 3. Looks like it goes up 3 every time it goes over 2. So it looks like now it has a slope of 3/2. So here's 1, here's 2. Put an open circle here at 3/2. And I'm going to draw a line that continues out like this. I'll throw an arrow on it because this has an arrow here saying it continues in that direction. Weird, huh? Here's the graph of the derivative of this function right here. Yours might not look exactly like this, but it should be pretty close, relatively speaking. That's part 1. Now part 2. Forget everything we just said, because we're about to kind of work backwards in part 2. So part 2 reads a little bit differently. Let's see, let me set up my scale. 1, 2, 3, -1, 2, 3, 4, 5. Part 2 says, okay, now suppose that the graph picture, this guy right here, is no longer my function. In fact, this is the derivative. So the height of this thing up here is now what I'm looking at. No longer looking at the slope of this thing, but rather the height of this thing. And it also gives me a little hint. It says, well, you're going to draw G and g of 0 equals 0. That means it must go through this point. Give me a starting spot at least. All right, so where do we go? Maybe we'll start from here. When x equals 0, the height of this graph is negative 3. What that means for the height to be negative 3 is that this graph better be going down pretty steep. Slope of negative 3 or so. Note that this line that I'm starting to draw is going down pretty quickly. And it continues to go down until I get over to here to positive 2. And at positive 2, the height is 0. So what that's saying is when I finally get to this point here, it should be flat. So it's going down pretty steep, and it starts having a less and less steep slope until it gets to x equals 2, at which point it kind of flattens off. So what I'm saying is I'm going to draw this guy to be kind of curving in. The slope's getting less and less steep, less and less steep. Finally it gets to, bam, this point at 2, where it's flat. Then what happens? Well, then it keeps going up. So over to the right of 2, the height of this is positive, meaning this should be increasing. So I'm going to draw something, looks something like this. And note it gets steeper and steeper and steeper because this keeps going up higher and higher and higher. So it's going to end up looking something like this. What about to this side? Well, let's see. When I'm at whatever the hell this is, somewhere between negative 1 and negative 2, maybe this is negative 1.5. The height's 0, so it better be flat. So what that means is when I get to this point right here, it better be flat. So what happens from here to here? Well, from here to here, the height of the derivative is a negative number, meaning it better be decreasing. So I got this point up here where it's flat, and then everywhere from here to here, it's decreasing. It's decreasing pretty quick. When I'm down here, it's got a slope of negative 3. So we got this steep negative slope. But it gets less and less steep as I get up here. And then finally, when my x value is negative 1.5, the height is 0. And then what happens? Well, it looks like it gets, the height of the derivative is bigger and bigger and bigger until I get to negative 3 here. So negative 1, 2, 3. So what I'm saying is, not only is this thing increasing from this point to this point, but the rate at which it's increasing by is slow when I'm near here, and it gets faster and faster and faster until I get there, until I get to negative 3 here. And then what happens at negative 3? The height goes down a little bit. It doesn't go down too much. It just goes down a tiny bit. So note, the height is still positive. The height's always going to be positive, meaning this graph is going up. From all the way over here, as far as I am to the right, it's always going up because the height of this is always positive. But the rate at which it goes up slows down a tiny bit. So maybe the slope is negative 3 here is going to slow down a tiny bit until I get to negative 4. And then it's going to start speeding up again. Get something that looks something like this. Something very subtle happening in here. Kind of between these 2 points, where the height is still positive, but it's kind of less and less positive for a little while. I guess we know enough about to talk about concavity, so I can kind of describe that. So really what happened is if you look at the derivative, so the weird stuff is going on over on this side. The derivative is decreasing from here to here. So what that means is it's concave down from here to here. It's an upside down bowl shape from here to here. And then it's increasing from negative 4 to negative 3. So from negative 4 to negative 3 is concave up. Kind of want to draw that a little bit more explicitly, even if I'm exaggerating some of the features of this graph. I think it'd be good for people to see that a little bit more. So what I'm saying is from this point here at negative 3 until it gets to negative 4, I still want it increasing, but I want it to do so concave up. Concave up, concave down. And then at this point here, the derivative is decreasing again, so it's again concave down. So I switch back over to this concave down thing. Maybe I'll even make note of that. From here to here, and then from here to here, we're concave down. And then maybe in another color, from here to here, and then from here this way, we're concave up. What are some other little notes that I could throw in here? Well, let's see. I guess we have, maybe I'll just quit it here. How long is this video? 10 minutes already. All right, time to stop. I mean, I kind of said everything for these comments. Not differentiable at 2 different points over here, here, and there. And then increasing everywhere where the derivative is positive, so we're increasing, decreasing, increasing, decreasing. But I think I'll leave it at that. I'll leave the comments up to you, because I did say put comments in if you feel like it, and frankly I don't feel like it. So I'm going to stop this video right here.